Oh, and I apologize in advance. Where I come from, it's 10 degrees Celsius. So believe it or not, I actually have a jacket in my hotel room that I wore to the airport on the way here. Whew, so if I sweat a lot, I'm not really acclimated to the climate here. All right, so let's get started. My name is Stephen Cleary. This is a talk about avoiding common pitfalls with async and await, or common mistakes. The quote here is a great quote from this guy who goes by Duality or Tuality. If you ever need to learn anything about JavaScript, his blog is the absolute best, and his books as well. He just published a blog post on async JavaScript a week before last, I think, and it had this quote in it, and I thought, I'm just going to steal that quote. So this is a link to his blog. This is not a link for the slides for my talk. That'll be at the end. I do want to say I have really enjoyed visiting Copenhagen, if I say that correctly. I wish that I had more than a couple of days here. It's a great place. So questions are welcome. You can ask them throughout this talk or at the end. I will be hanging around a little bit afterwards if you want, or I'll be here the rest of the day, of course. And also the context for this talk. A lot of sources for async and await knowledge on the internet kind of assume either you're writing a client application or a mobile application, or they assume you're on the server side. The context for this talk, unless I specify otherwise, some of the slides are specific, but most of the context for this talk is all .NET code. Okay. So, who am I? All right, I'm a guy whose clicker doesn't work. That's who I am. So I'm Stephen Cleary. If you look at my little bio blurb online, I list several things before developer, because those are the most important things in my life, all right? And I'm just gonna say, I don't base my identity in being a developer. So if AI takes over our jobs, personally, I do not think it will, but if AI does take over our jobs, then I would be kind of bummed because I love software development, but I wouldn't really be like completely devastated because that's not who I define who I am. I think that's kind of an unhealthy mindset that some of us get into. Ooh, and my mic is slipping off. Could I get a mic help up here? From one of the audio guys in the back? Thank you. All right, so I'm a Microsoft MVP, top async and await answerer on Stack Overflow, etc. I've got a lot of async knowledge all over the internet. I also wrote a book. I make almost $2 US for every book sold. Sorry, I don't set the prices. But this is, funding my retirement, so that would be greatly appreciated. I'm just kidding. Okay, so let's talk about async. Now, I do want to talk a little bit about the syntax right at the very beginning. And I hate taking the time for this, especially because the time for this talk is already limited. But it is 2025, and a lot of people actually don't know how async and await works, which is fine. But I actually heard somebody teach it wrong at a developer conference earlier this year, and I was like, ooh, okay, I guess we still need to cover the basics as well. So when we're looking at the async keyword first, so there's two keywords, there's async and then there's await. When you look at the async keyword, it can only be applied to a method, and it does two things. The first thing it does is it enables the await keyword for that method, and the second thing it does is it transforms your code in that method into a state machine. Now, the way that this works is actually very similar to the way the yield keyword works. Most people haven't used the yield keyword, but it is a very similar kind of transition where it actually breaks up that code at all the await points into different states in the state machine. Okay, could use some help with the mic here. It keeps sliding off. Talking about the async state machine. There we go. All right. So, like I mentioned, the async keyword enables the await keyword, and then it also transforms your method into a state machine. So let's just take a quick look at what this looks like. This is a QR code for what this actually looks like, by the way. So I'm just going to follow this link. Actually, you know what? I already did. Okay. So here's our async code in here, and this is just a really dumb asynchronous method, okay? I'm calling out to Google, I'm calling out to Microsoft, I'm getting the string of their home pages, and then I add those strings together and I return it. It's just example code, all right? So this is what the compiler actually generates over here, and as you can see, it actually generated a class for this method. The details of this change from compiler to compiler, whether you're in debug or release, but the general idea is the same. You have this type now that represents your method, and you've got this important state member. So this is the numerical state that this method is in. So as it passes through its state machine, it goes into different states. And then it lifts your local variables, like the first and the second, into members on this class, and then down here's in the move next method. Sorry, I almost skipped past that. Move next you may recognize from your stack traces. Okay. Move next is the method that actually executes the next step in the state machine. All right, and I believe that, I can't prove this, but I believe that whoever originally implemented async and await just copied the code from enumerable with the yield keyword, because that one actually has a move next method that makes sense. This one it still has a move next method, but it's like, why is it called move next? Yeah. Anyway, because the code transformations are very similar. So, like I said, can't prove it, but that's my theory. So this just walks through and goes and looks at the different states. Your num is copied from your state variable here, and then for each state, it has your code actually going into here. So you've got this get string async for Google. In another state, you've got the get string async for Microsoft, and then you've got, eventually they get added together here. Yeah, here it is. Oh, it converted it to string.concat, yeah. So, your code ends up being in this method as part of the state machine. Now, most of the time, you don't really need to know the details of this. If you're really interested, I think John Skeet has a great blog post called EduAsync. It's like 10 years old, and the exact details are very different, but it's still the best resource that I know of if you really want to go deep into that. Yes. All right. So that was await. That was async. Now let's look at the await keyword. The await keyword takes a promise, okay, or a future. In .NET, this is usually task or value task. And the await is where things can actually work asynchronously. Now this little call out here is just emphasizing the fact that we do not actually await methods. We talk about awaiting methods. Like if I were to read this code on the left, I would say, well, yeah, we're awaiting task.delay. That's just a phrase that we use. We're awaiting the method. Technically, we're actually calling the method, getting a task back, and then we're awaiting that task. There are times when that distinction is important. And await and async compose more naturally because do nothing async can also be awaited by something that calls it. And it can be awaited not because it has the async keyword, but because it's returning a task. Okay, because it's the task that is awaitable, not the method, right? And await is where things actually get asynchronous. So this code on the left behaves as though it's on the right, with calling task.delay first, and that's actually a synchronous call. It's just like a perfectly normal call. There's no magic that happens until the await. So when this method calls task.delay, it's actually calling it synchronously right on the same thread and everything, and then it gets a task back representing that delay that'll complete when that delay expires, and then we await that task, and that's what makes this method asynchronous. Okay, so the exact way that await works is first it examines its awaitable, or its task or value task, and it says, are you already done? If it is done, it just continues executing synchronously. That can happen in some surprising scenarios, like in mobile platforms. Sometimes even your HTTP calls will complete synchronously because they could be cached. As far as I know, that doesn't happen on the desktop. But yeah, so sometimes you can have surprising behavior when await just continues synchronously. It can happen. Now, if it's not complete, which is most of the time, then it continues asynchronously. And what I mean by that is it sticks a bookmark in the method, right? It pauses the method and registers the remainder of that method with a task, and then it returns. And the way that this actually is done is it's setting that state, that integer variable to this is the next part of the method I want to execute, and then returns an incomplete task. Now, in this example code here, it's getting back a task.delay. Let's assume it hasn't completed, right? Technically, it could if something happened that blocked the machine for 100 milliseconds before we actually checked it. but let's assume it's not complete, then do nothing async would return an incomplete method to its caller, okay? And then later on, the task returned from task.delay is going to complete. So let's look at what happens when that happens, okay? So when task.delay completes, then it's using the state machine to resume at the right place in the method, so it's coming in after that task.delay, or after that await, and in this case, there's nothing else to do. It just returns. But technically, it is resuming. Now, when it resumes executing code, that code needs somewhere to live. Okay, when you're talking about something like task.delay, one of the major misunderstandings that we'll cover in just a sec is that await does not run things on a background thread. Okay, it does not do that. There's the await, or the task.delay here is just returning a task that will complete sometime later. There's no thread associated with that. Now, when it completes and it executes the rest of your method, that code has to run somewhere, right? It has to choose a thread. So where does it resume? Well, by default, await, before it actually pauses, or when it actually pauses the method, so when it behaves asynchronously, it will capture the current context. And this is the current synchronization context or the current task scheduler. Almost no one uses task schedulers anymore. So it's usually a synchronization context, and usually this only applies if you're running in a UI application, because you have a synchronization context that defines the UI context. So the UI thread in UI apps is special. Nothing else can touch the UI members except for the UI thread. Now, there is also, if you're running ASP.NET pre-core, like you're still in .NET Framework, anybody? Yeah? Okay, yep. You're not alone, I know. So if you're running pre-core, then ASP.NET also has a context. It's a request context. It's not tied to a specific thread, but it does have a context that the code resumes in. Okay, so I do want to talk a little bit first about some conceptual mistakes. This is more like mistakes in design or thinking about async. So really like big picture to start. So the first off, like I said, await does not mean run on a thread pool. Sometimes people really confuse async and parallel. I see these as like two different solutions for a similar problem. We want to do more than one thing at the same time. We want to do concurrency. But parallel is throwing more threads at the problem. Async is actually using fewer threads to solve the problem. Now you can do both at the same time. Like there's a parallel for each async, or for each async, I think that's correct. So there are some where you can say, throw a bunch of threads at this and do asynchronous work. But in general, parallelism and asynchrony are like two different ways of achieving concurrency. Another conceptual mistake is to just say, async is faster. Okay? I see this one, I used to see this one a lot more, I should say, a few years ago. It's not actually faster. Technically, async code is a little bit slower for reasons that we won't get into today. But you get benefits from asynchronous code. On the server side, you get much more scalability because you're using fewer threads to serve the same requests, or many more requests, actually. And on the UI side, you get better responsiveness, right? The whole point on the UI side of async on the UI side is to free up that UI thread, that special UI thread, so that it can interact with the user and keep your application responsive. So when I'm trying to figure out async problems, this is especially the case with questions I answer on Stack Overflow, with consulting work that I do. There are 3 different kind of conceptual models. So everything before this has been like stuff I've done 100 times in different talks. So I went a little fast. Hopefully I didn't lose anyone. Now we're into the new stuff. So there are 3 conceptual models that I switch between. And I find it useful to think about async different ways when thinking about it in different problems. So I'm just going to run through each of these 3, and then we'll just take a look at a quick example. So the first one, this is kind of how I describe async and await, like when I described the keywords. The way that I think of it is await means asynchronous wait, right? This method is going to asynchronously wait for that task to complete. I don't know if that's what it actually stands for or not. I never asked, but that's how I think of it. And then the task itself represents the execution of that method. So when that method concludes, when it completes, then that task is completed. If the method returns a value, then that value is placed on that task. If the method throws an exception, then that exception is placed on that task. Okay, so the task kind of represents this asynchronous method executing. And then, like I said earlier, await pauses the method's execution. This is kind of like my default mental model, and it works in most cases. Am I on? There we go. Okay, all right. And this mental model, I think, works in most cases. But there are a couple other mental models that are also very useful. One is thinking of it as like types. Okay, so in this case, you can think of it as like a type wrapper, okay, or an unwrapper. And task of t, like I said, is a future, all right? It's a future value of t. It's a t that will resolve at some future time. And when you have an async method, that will wrap your return values, okay? So it's wrapping it in a t. This helps answer questions like, well, I have a method returning task of int. Why do I return int instead of task of int? It's because the async is doing the wrapping of that return value for you. And then the await unwraps that value from the task. So sometimes people are like, well, I have this task of string or whatever. How do I get the string out of it? Well, you use await. That's the proper way to do that. Okay, so we'll look at more of the typed examples in a little bit. And then the final one is, this is like closer to how the async and await actually works. The other two are nice to help solve problems quickly with. This one takes a little bit more work, but this is actually how it works. So we covered how async chops up your method into a state machine, and the await, every single await keyword is where those chopping points are. Okay? And then when the await yields, that is when it acts asynchronously, then it registers the next method chunk as a callback on that task. Now, the interesting part about this is that you end up with an inverted stack at runtime. Because you've got like method A, the asynchronous method, and then that calls method B, and then that calls task.delay or whatever, HTTP client. And then when that task completes, it resumes method B. And then method B, if that task completes, then it resumes method A. So when you're calling into those methods, you're calling method A, method B, task.delay. And then when you see your stack at runtime, it's some timer thread pool, the timer's complete thread, then calls method B to complete its task, which then calls method A to complete its task, and then you can see an inverted call stack. And that's perfectly normal, and because that's how async and await is supposed to work. It's all callbacks, actually. And that's also how the GC, the garbage collector, is able to maintain everything, because it's all rooted by that timer callback or that HTTP callback. That's rooted by the garbage collector, and that's what keeps your tasks alive, even if you don't keep a reference to them, which you should. We'll cover that in a minute. Okay. So here we go. So here's a simple application. I'm just calling Google, and then I'm returning how big their web page is. So if we run this, can't really see it, but Google's about 50K right now. All right, good to know. That's really important information. Okay. So normally I think about this as the await is doing an asynchronous wait, and we also have like this idea of the type wrapper. So I'm returning an integer, even though my return type is task event, because the async is doing the wrapping for me. And then when I come up here and call it, download something async, then I await it to get out that integer, right? So this is both conceptual models are pretty straightforward here. Now I'm going to do this. This is the same exact code. I'm just splitting it up a little bit more. So we are pulling out, or we're getting this task back, and then we're awaiting the task, remember, because this is the same thing that this code up here is doing. and then we pull out the response to length. Now what I want to see here is, you know what, actually, I'll get that, no, okay, didn't get it in time. All right, so in this call stack now, I can see, where, oh boy. Okay, I apologize. Visual Studio is smarter than the last time I ran this demo. It's actually showing you the call stack you would expect. Okay, so, but normally, like if you're logging or something, you would see an inverted call stack at this point. Pretend it was inverted. That's normal. All right. Ooh, that's a good point. I should do my other demo here too. Let me pop over to my WPF app. And what I've got over here is, this is just demoing the fact that await will capture that synchronization context and use it to resume. Okay, so first I say, I just have this simple method where I say hi, and 2 seconds later I stay still here, which works. Good. And the way that this works is when you have an await, it captures that UI synchronization context, and then it uses that to resume so that this code down here can still directly access that UI, okay? All right, that is most of the basics. Okay, sometimes it's helpful, and I don't have this as like a separate conceptualization, but sometimes it's helpful to remember that the task is just an object, okay? There's nothing magic about task. The .NET runtime, at least right now, does not have any specialized knowledge of task. They're thinking about adding it just for performance reasons. But right now, it's just treating it like literally any other object. So you can actually save your task in a variable and await it later. You know, well, I want to start this asynchronous work, but I don't want to await for it to complete right here. Well, you can just save it in a variable and await it later. That works just fine. And it also composes very naturally with a lot of other types. You could have a list of tasks, right? Which is, you've started a whole bunch of things, and now you are just going to await for them all to complete. You can do that with task.whenAll. So you have like a collection. Now you're doing asynchronous concurrency, right? I wouldn't call it parallelism because you're not using multiple threads. But you have asynchronous concurrency with this list of tasks. You're just sticking the task objects into a list. Works just fine. You also have func of task, right? Now here's something that a lot of people, they don't really realize right away. Well, I have this asynchronous code that I want to define now, but I want to run it later. Okay, well, how do you do that with synchronous code? You stick it in a delegate, right? You stick it in an action or a func of whatever it's returning, and then you execute that action, that delegate later. Well, you do the same thing with asynchronous code. It's just a func of task. So it's a function, a regular old lambda that just happens to return a task. And there's your asynchronous delegate right there. It just flows right into the rest of the language. Something a little bit trickier to think about is a lazy of task. Okay, so here's something that you want, you would use something like this, or an async lazy, really, in my async EX library. You would want something like this if you want a whole bunch of parts of the code. Well, what do you normally use lazy for, right? It's a lazy initialized value. You don't want to initialize it right away. A whole bunch of other pieces of code can all initialize that at the same time. They can call into it at the same time, but the initialization only runs once and evaluates that result once. And then they all get the same result. Well, the same thing's happening here. It's a lazy of task of t. You're just having that lazy encapsulate a task instead of the actual t value. And so you can have asynchronous lazy initialization as well. So when you kind of cross that bridge of, oh yeah, you know, a task is just an object, you can use it with any other objects in the .NET ecosystem. Okay, I mentioned ValueTask a couple times. I do want to cover the ValueTask rules, all right? Anybody using ValueTask right now? Okay, a handful. All right, cool. So when it first came out, I don't remember who it was, but somebody was like, oh yeah, everybody should use this. And I was like, okay, yes, eventually. And now I think he's more right. I would say yes, go ahead and adopt ValueTask now, because it's been around for a few years. A lot of people are a lot more familiar with it. Here's the rules for it. You can show these to your teammates. So essentially, there are 2 rules. You only consume it one time, all right? Because value tasks are a mutable value type, so you can't consume it twice. And you don't block on it, all right? The blocking is especially scary. I wish that they had been able to do a different API for value tasks, because if you're replacing task with a value task in your code base and you have existing blocking code, it may or may not work, and it might, this is the scary part, it might work now and then fail at runtime later, because the value task implementation can change. So you never block on value tasks. It's just officially not supported. Okay, so are we all ready for the actual, that's all the groundwork of conceptualizing async the right way. Are you all ready for seeing mistakes? Here we go. There's 2 big ones, all right? Anybody seen async talks or been pretty familiar? Okay, a handful, okay. So there are 2 big ones that everybody talks about. One is avoid async void. One reason for that is, like I said, in your default conceptualization, the task represents the execution of that method, right? It completes when the method completes. If the method throws an exception, it gets placed on the task. Well, with void, you're literally saying, okay, start this asynchronous work, and I don't care about when and if it completes. So it has like special exception handling rules. You can look that up in my article here that's linked here and the QR code if you want to know all the details. But the problem is, like your calling code can't know when that's completed. And this is important because it has to support being shut down, okay? So your calling code has to know when it's safe to exit. Have I completed all of my work? Doesn't matter if you're a mobile app developer saying, okay, can I be put to sleep right now by the OS? Or on the desktop app, oh, the user clicked the X button, is it safe to exit? Or in an ASP.NET app, right, where you have a rolling deployment coming through and you're saying, oh, hold on, I have asynchronous code I need to finish up before you shut me down. Your code really has to be aware of all of its work in order to safely say, can I shut down or not? And if you use async void, you can't have that. An interesting thing is that async and await has been adopted by several other languages, right? At this point, I think Python was an early one, JavaScript. Those are like the 2 really big ones, but it's really in a whole bunch of other languages, and the interesting thing is none of them have async void. C# is the only one that has async void. It's not a natural fit. I understand why they added it. It was just to make event handlers easier. But it's not a natural fit for the conceptualizing async and await. And the second guideline that you'll see is do not block on asynchronous code, okay? So again, I have a link to, I think this one's a link to my blog. The previous one was to a paper of mine. So when we talked about how await captures that context, right? That synchronization context, that's usually a UI thread, unless you're on the old ASP.NET framework, then that's a request context. Well, both of those contexts, both the UI and the ASP.NET one, only allow one thread in at a time. So if you are in that context and you're blocking you're synchronously blocking on a task to complete, this is .result, this is .wait, or getAwait or getResult. All 3 of those are different ways of blocking on it. Then you will deadlock your code, because the other code further on down the stack is trying to resume executing so it can complete that task, but it's trying to resume on that captured context, and you're blocking a thread in that context, and that context only allows in one thread at a time. So I was asked a while ago, okay, ASP.NET Core doesn't have a synchronization context. We won't deadlock if we block, right? Yes, that's technically true. You still really shouldn't do it, and here's why. When you're blocking on asynchronous code, you're using up a thread pool. You're using up a thread to actually wait for that task to complete. And when you're on ASP.NET World, your code actually requires another thread pool thread then to complete that method before passing it back to the thread that's waiting for it. So your handler, instead of using 0 threads most of the time, actually requires 2 threads to make progress. And you're killing your scalability when you do this. You can run into thread pool exhaustion, which I've had to diagnose several times. Not fun. But actually, I think every single time I've done consulting work to diagnose thread pool exhaustion on ASP.NET, every single time it was because they were blocking on a task. They thought, I'm on core. I don't have to worry about deadlocks. Right, but you still have to worry about thread pool exhaustion. And it's a nasty thing to get out of. All right, I'm planning a blog post about that someday, whenever I get a chance. Okay, so those were the 2 really big the 2 really big mistakes. The 2 really big mistakes are async void and blocking on asynchronous code. So let's take a look at a bunch of other mistakes, and now we're going to jump into some code. All right. I've got an async void method here, example. Okay, the problem here is that this caller is calling into this example async void method, and it doesn't have a way to catch exceptions. You cannot write a try catch here and have it work, okay? No try catch here is going to work. If you wrap this up, this is not going to do what you think it does. Oh, look at that. Good job, Copilot. All right. You're right. So try catch is not going to work. You can't know when it's completed, right? When is this code, if this is sending an email or something, when is this code actually going to complete? Because if you get you're doing a rolling deployment or something, you get your whole app domain yanked out from under you, sorry, that email's not getting sent. No messages, no errors, no exceptions, you just drop out of memory. Okay? That's what async void does for you. And actually, if this does throw an exception, it goes to the top level handler for your application. So some people call this fire and forget. I call it more fire and crash, because if anything in here, in this async void method, if an exception ever escapes from this method, then your application is crashing. Okay, so you just don't use async void unless you're doing event handlers most of the time. So the clear way to solve this is to make it return task, and then you make the caller async and change its void into a task as well. And async, this is something that sometimes, I shouldn't say sometimes, we have all found this very annoying, right? Because you make one method async. Well, now everything it calls has to be async, and everything they call has to be async. This is natural. This is normal. That is proper. I know it's super annoying, but it is actually the way it's supposed to be. I'm sorry. Well, not me. I didn't make async, but whatever. All right. So the other thing that we talked about already is blocking on asynchronous code. Here I'm calling that same, or here, actually I'm calling this example task, and I'm calling it, and I'm blocking here. Now this code is just a fancier way of saying .wait, or if this was returning something, I could say .result too. And the problem with this is that code will deadlock if you're in a single threaded synchronization context. So UI thread, ASP.NET Precore. Even if it doesn't deadlock, you're burning your thread pool threads. You're asking for thread pool starvation if you're in any kind of server scenario. Okay. Occasionally, you could get away with doing this, like in a thread pool thread on a UI app. Okay, so really kind of obscure scenarios, you can do this. All right, but generally speaking, this is a mistake. And instead, what you want to do is say, await, yes. And once again, this becomes async task, and your async grows throughout your code base. Okay. I do have talks and blogs and articles that I've written on how to do this in a brownfield application. Because sooner or later you hit constructors that were doing like I/O and stuff, which they never should have been doing in the first place. You run into events, properties. You're calling a get property, and it's actually like doing some HTTP requests. All right, shouldn't have been doing that. So I walk through like, here's how you like migrate all these different scenarios. I can't cover that today for sake of time. But this is the natural and correct way to deal with this, is to let async grow through your code base. All right, enough about those, because everybody talks about those. Let's talk about some new ones. So these are things I haven't covered in the slides yet. All the rest of these will be covered in the rest of the slides. So the first one is fire and forget. Okay, now you could say, like, some people call, like I said, async void fire and forget. I call it fire and crash. But then you could do this instead. Well, all right, I'm just going to discard that task. And that's what I'm doing here with that underscore, is I'm saying I'm just going to completely ignore that task. Or sometimes you will find the code saying like that. All right, I'm calling an asynchronous method. Not doing anything with the task it returns. Well, the problem with this is the same problem that you have with any other fire and forget, and that is your application can't know when it's completed, can't know when it's safe to shut down. Any exceptions, with async void, exceptions will crash your process. In this case, exceptions will be captured and placed on the task, and your code is ignoring the task. So all your exceptions are silently ignored. Not much better. And of course, the correct way to deal with this is use await. I'm sensing a pattern here. Oh yeah, if we just use await everywhere, things work a lot better. Okay, let's move on. The next one I want to talk about is there are some methods on task, or some members, I should say, on task that really shouldn't be used or should be strongly avoided. Okay, so one is continue with. Continue with is dangerous, all right? I have a blog post that goes into details. But essentially, you shouldn't be using continue with, okay? For the vast majority of code, you should not be using continue with. What do you use instead? Any guesses? Anyone? Oh, wait, I heard it. Yeah, right. Okay, so here we've got some code that we want to run when this task completes. That's awesome. So let's run it when the task completes. There you go. We're using await now. The code is cleaner, it's simpler. Question? Okay, so he has a point. He wants to use continue with when he's trying to deal with async events, correct? In order to observe all the completions of all those event handlers. I'm actually going to cover async events a little bit later in this talk, if that's okay. But I actually have several blog posts also on it. Oh boy, the guy next door is already done. Man, I better hurry. Okay, so start new is also dangerous for the same reason as continue with. Both continue with and start new existed before async and await. A lot of people aren't aware of this. They didn't learn about task until async and await came in .NET 4.5. But task was actually introduced along with continue with and start new and the task constructor, all in .NET 4.0. These are .NET 4.0 era APIs before async and await. They really don't work perfectly with async and await. Start new is also dangerous. I have a blog post on that as well. So what do you do instead? Task.run, all right? And you would await the task here. I forgot to do that in this no Copilot. And then you would await the task here. All right, so you would use task.run to put things on the thread pool thread, okay? All right, and the task constructor. Now start new, continue with, these are things that they do have like very niche use cases, okay? Like it's very, very rare, but sometimes you do need to use them. The task constructor should literally never be used, ever. Okay? There are no use cases for the task constructor, so don't ever use it. I'm not going to show the replacement here because people use the task constructor. They're trying to do different things. Sometimes they want code that'll run later, and they should be using a func of task, right? The delegate that we talked about. Sometimes they want to run code on the thread pool thread, but they're not aware of task.run, which is to run code on a thread pool thread. So it depends on how what you're trying to do as to what the correct code looks like. All right, let's jump into side effects. Now this is more of a guideline, okay? But it's useful to have asynchronous methods not actually cause side effects. Okay, so they're like updating some kind of code outside of their method, right? So here I've got a local variable value, and this side effect does something for a second, and then it sets the value. And the problem here is, your calling code doesn't have to await the task right away. It gets back a task. That's fine. It doesn't have to await the task right away, but in between it's starting and when the task is completed, what is the value, right? It exists. We just don't know what it is. Now, if we await it before we print the value, it's 42. If we print the value before that, who knows? We don't know. Unless it's explicitly documented, right? So instead, this is more like a guideline, okay? But it's usually cleaner to return the results instead of sticking them somewhere, like in a dictionary or something. It's usually cleaner to return the results of whatever your asynchronous method is. And then you can have a task of, and then when you await the task here, now there is no member variable, right? And now you can pull it out of the task. You're getting the result of that task. Okay, so async and await will actually kind of gently push you towards this more functional programming style that is better for your code. Okay, it's not going to push you really hard, but it'll gently push you. Okay, so let's talk about eliding. Eliding is to do away with something. Okay, so I've got this do something async method. Now, there are different things that we can try to get away with. So async and await has a little bit of overhead. And you know what I say? Don't worry about it. The number of times I've had to optimize away async and await for performance reasons is 0, okay? I've never had to do that because I don't work on the .NET framework team, okay? They have to do stuff like that. We don't have to do that. So what I generally do these days is if we've got this method here, and we've got like some overload for it, I've got an overload here without a cancellation token. So if we want to do an overload for it, fine. Okay, we can do that. We can get rid of the async and await. That's fine. And we just return the task directly. I'm okay with that. All right? Pretty much every other scenario where you're thinking about getting rid of the async and await keywords, don't. All right? Pretty much don't do it. So here's a couple of more serious reasons why not. Here's one where I got rid of that async and await, and so I've got this cancellation token source I'm newing up, and it's in a using. Okay, so I'm actually calling this in the using block, and I'm just returning the task. Now the problem is, this is running synchronously, right? There's no async keyword here. So I'm newing up a cancellation token source, I'm calling do something async, I get back a task from that method that is going to complete when that method completes, and then I'm disposing the cancellation token source that I just passed into that method, and then I'm returning the task that I got from that method. This is not going to work, right? Your cancellation token source is going to be exposed or disposed when do something async is still running. Okay, so the way to fix this, I wonder what it could be. Oh yeah, use async and await. Now it works. Now it works the way you think it would work. Oh, and we don't need the return because there's actually no return value there. All right. So now this code is actually going to work the way you think it is. Very similar problem with try catch, right? Because I'm going to call do something async, get back a task. Well, that task represents the execution of that method, right? If that method throws an exception, where's it going? It's going on the task. It's not going here. It's not going to this catch block. It's going on the task. But I just returned that task. I'm not even watching it anymore. I'm outside of this call frame. And I will never catch this exception, right? So this handle exceptions is never actually going to execute, okay? Instead, to fix this, async and await. Definitely a pattern. Okay, so now this will actually work as you expect. It will actually catch exceptions that do something async throws because that await observes the task and rethrows any exceptions that are captured on it. Okay, so these are problems that we run into sometimes when we try to do some premature optimization. We're like, oh, we don't need async and await and the state machine overhead. Well, it's not adding that much. You'll be fine. All right. Again, it's fine if you're just doing basic overloads. If I was even doing anything in here like calculate default parameter, I wouldn't even do this, okay? If I'm doing anything else in this code, I'm like, nope, I'm using async and await, all right? Okay, moving on. Here's one that's come up relatively recently. I don't remember what version of .NET Wait Async was introduced in, 6 or 7 maybe. It's pretty recent. So you can call wait async on any method and pass in a cancellation token, and then this await will be canceled if that cancellation token is fired. Now the problem is that people fall into the mental trap of saying, well, okay, that means that the delay was canceled. No, it's not, okay? The underlying task here that you call wait async on is not canceled. The cancellation token passed into wait async cancels the wait. It does not cancel the task, okay? That's the important thing. That cancellation token cancels the wait, the asynchronous wait, not the task. All right, so the proper way to do this is to pass it in. And if your task does not, or if your method you're calling does not support cancellation token, I want to say too bad, but there is a way to handle it, but it's extremely complex. I'm planning a blog post on that one too. Essentially, you have to wrap it into a separate process and execute that, and then kill that process if you want it to cancel. That's the short answer. Actually doing that is the long part. Most people hear that and they're like, never mind, we're fine with it not canceling. All right, so the next common async mistake that we see is what I call fake async methods. This is a method with an asynchronous signature, and it's returning a task, okay? But instead of actually doing anything asynchronous, they just wrap the entire method body into task.run. Okay? So all we're doing is we're taking synchronous code, the synchronous implementation, and we're throwing it on a thread pool thread and saying, look, an asynchronous method. That's not really an asynchronous method. You're still burning a thread. As a general rule, I say use task.run when you're calling synchronous code, if you need to, which is usually just in UI applications and you want to keep the UI responsive. You use task.run to call code, await task.run. You don't want to use task.run to implement a method. Okay, so you having this kind of like top-level task.run where everything in the method is inside this, that I would say is definitely a code smell. All right, so we're getting a little bit more esoteric here. Sometimes you have a scenario where you want to process tasks as they complete. Okay, we talked earlier about list of tasks, right? Here's an example. This method takes a list of strings, a bunch of URLs, and then it uses link, good old link to objects, to say, all right, for each one of these URLs, I want you to download it as a string. Okay, so now it's getting back a list of tasks of string. And these are all tasks that are all executing. They're all downloading all these different URLs all at the same time. We're using asynchronous concurrency here, all right? Now, how do we process these one at a time? We want to, in this case, I'm just going to take the result of those, and I want to write it out to the console. Okay, each string, as it's downloaded, I want to write it out to the console. I don't want to walk through this list in order, because that's not the order in which they downloaded. I want to display each one as they download. Okay, so this is the problem that we have to solve. And this is a solution that is everywhere on the blogs and everything. I don't care for it. I would say I disagree with it. And this is, well, you just hang out here while you have more tasks. You grab the next one to complete. This is all fine. You remove it from the list, and then you can process its result. I think that this is a very awkward way of doing this. The proper mental model is to remember that async and await composes, okay? Async gives you a way to compose asynchronous operations using await. So use that. What we can do is say, how do I want to write this? I want to say, actually, what I would do here is like a download and display, okay? And this is an asynchronous method. And here what I'm doing is I'm taking this part here from my select, and I'm saying, I'm sticking it down here, and then I'm taking this part here, what I want to do after it's completed, and I stick it down here. Now that I've got this composition here, this is a composing method where I'm doing something asynchronous and then I'm doing something with the result, and now it's one method that does both things. Now I can just stick this over here, right? This is now download and display. And, right, because it's not returning the string anymore, sorry. Okay, and then all you have to do is await task.whenAll, and all the rest of this goes away. Doing the same thing, but I think it's much cleaner using that composing method. Okay? Sometimes you can't replace this part. Okay, sometimes you can't replace the select, and in that case, you can still do things like, so let's pretend that this task here is like passed into this method. We have no control over how it's created. Okay, let's just pretend that for a second. So our tasks are now our input instead of the URLs. Instead of doing this, what I would want to do is we can do a task of string. And now this is our, I'll just call it text. Okay. This is a horrible method or parameter name. Please don't blame me. All right. So we've got our task of string. Now I'm still composing, right? I can just await. I can pass the task as an object into this method. The method just awaits the task and then dumps the result. It's still composing that asynchronous work, and I can do that. I don't want to do this at all. So let's pretend that tasks is our input now. And I can do this. Parentheses. But there. Now I'm still able to just do this in a single line of code and say when all these tasks complete. And so I'm composing them and then waiting for them all to complete. I think this is a much cleaner solution than this kind of while the list is not empty kind of thing. Okay? All right. There are very rare situations where you do have to handle tasks as they complete. Generally, I say if you possibly can, use composition instead of handling tasks as they complete. But if you really, really do, .NET 9 added task.whenEach, which you can await for each over. Okay? That's the basic usage right there. And on older .NET versions, in my AsyncEX library, I have an order by completion extension method that you can use with a regular old for each, because in the old .NET framework stuff, they don't have async enumerables. And this does the same exact thing as task.whenEach. Okay, we got one more. Here we go. Ooh. So this is another thing that I see. Sometimes this pattern is really common in Node.js, okay, where I'm going to call this asynchronous method, and then I'm going to pass a couple of callbacks, one or two callbacks, depending on your framework, to invoke when this completes. Well, with task, you don't need that, right? You don't have to do this on result and on error, because the task itself is the callback, okay? So you can just like delete all of this and just use await to run code after the task completes. Okay, here we go. So super, super fast, right? Don't fire and forget. There are certain methods you should never use. In my notes here I have, do you work for Microsoft? Do you have Stephen Tobe on speed dial? All right, no, then don't use them. All right, thank you. Okay. Try not to use side effects. accept the more functional style, like stream.position, right? If you're in the middle of a read async call, what is the value of stream.position? I don't know. I don't think they even documented it yet. All right. Don't get rid of async and await unless it's just a very, very simple overload. All right. Now, if you use task.fromResult, task.fromResult is okay to use if you have like an interface implementation that you're stubbing out for testing or something like that. Okay. But you don't want to use it in your production code. Most of the time. That's a guideline, right? This is not a hard and fast rule. It's a guideline. All right. Don't misunderstand wait async. Wait async cancels the wait, not the task. Don't implement using task.run. You can call methods using task.run, but don't implement them that way. The when any and remove, which we just looked at, use composition if at all possible. And then, unnecessary callbacks. We don't need that. Okay, do we have time? We have 3 minutes for a bonus round. Okay, here we go. We can do it. So one mistake that I see is people use configure false to avoid deadlocks. We talked about deadlocks when blocking code. And they try to use configure await false to avoid deadlocks. The problem is you have to use configure await false everywhere. And so does every library you use. And so does the .NET Framework. The .NET Framework uses it everywhere, as far as I know today. But in the past, on the mobile SKU, it actually had a bug where they didn't use it once in HTTP client. So you could actually deadlock your mobile app. As far as I know, .NET Framework uses it everywhere today. But it's still just not a good idea to block the UI thread. I mean, you're going through all this work in order to block your UI thread and give your users a terrible user experience. Why would you even do that? It's better to do that, to take a different approach. Okay, finally, async events. Oops, I'm sorry. Woohoo! All right, too dynamic. All right, async events. I might go just a couple minutes over, I'm sorry. We could talk more about this later if you want more detailed information. But essentially the idea is anytime you have an asynchronous event where you have a delegate that's returning a task or a task like, and you have to like collect all the tasks and collect all the results because you have to figure out if any of them threw exceptions, or you have to figure out if any of them returned any values is another thing. So here's the problem. The design of your type is wrong. Events are supposed to do the observer pattern, okay? And async void works great with the observer pattern. The problem that we have here is we're using events as an implementation of the strategy pattern. When I say patterns here, I'm talking about design patterns, the old Gang of Four book. I can't remember. Anyway, yeah, design patterns. So what should be used to implement an observer is we're using that language feature to implement a strategy pattern. And the solution is that those actually shouldn't be events. Most of the time, it should actually be an interface, right? That's passed to that type, and that interface might only have one method on it, and it would be an asynchronous method. But most of the time, that is the solution so that you don't have asynchronous events. Now, can you actually collect them all and do that? Yes, you can collect all of your, I forget what it's called, but you collect all the delegates that have been registered with that delegate instance, and then you invoke them all, and then you use task.whenAll, is what I would use instead of continue with, is task.whenAll. You can do that, but it's really actually an indication that your design isn't quite correct. Okay, the last mistake that I see is people not aware of things that already exist in the framework. Okay, cancellation has already been implemented. Progress reporting has already been implemented. Producer-consumer queues have already been implemented. We're not going to do it because I'm already over time. But the channels, right? That sample code is available right here. This is slides and sample code for the talk today, including the channel stuff, which we didn't get to cover. But there's a basic example of channels and of just how to set up a producer and consumer using system threading channels, as well as the WPF app has cancellation and progress examples of how to use those. They already exist. You don't have to invent them yourselves. Okay. All right, and And I think that is it. We are 1 minute over. Thank you very much, and thank you to the guys in the back.